Hello everyone and welcome to TrenchBoot Developer Forum 2021. Today I will talk about TreeMDep contribution to TrenchBoot project. The presentation was made by Michał Żykowski and me. So who am I? I'm Piotr Król, TreeMDep founder. I'm open source software contributor, conference speaker, organizer. I'm also former Intel BIOS software engineer. I'm 12 years in business, 6 years contributing to open source firmware, and I'm also have C-level position in some other companies which logos you see here on this slide. Who we are, what's TreeMDep about? TreeMDep is a core boot licensed service provider since 2016, so we're doing core boot development, open source firmware development. We are in core boot project leadership. We also are UEFI adopters since 2018. We are also consultants of official consultants of Linux Foundation FWPD LVFS project, as well as Yocto participants and embedded Linux experts. We evangelizing usage of open source firmware, and we are highly enthusiastic about it. So first of all, I would like to thank a bunch of people without whom the contribution that I will present here would not be possible. So first of all, Daniel Smith for creating TrenchBoot project, Rich for motivating every one of us to move things forward, Andrew for highly technical discussions and reviews, Daniel Kipper for Grab consulting and discussing about Grab implementation, Ross for LZ and kernel development, and Christopher for support in Yocto Meta TrenchBoot and other area related to Yocto project. Of course, it would not be possible without TreeMDep team support. First of all, Christian, who made a lot of contribution, as well as Michał, Norbert, who did Chara related stuff and a lot of Yocto, Maciej for guiding Yocto related development and contribution, as well as whole test automation team, which added the hardware validation lab and be able to verify all the newest version of the code that we developed. And finally, NLNet Foundation for sponsoring bunch of this project. So how the TreeMDep contribution stack look like? First of all, let's start with hardware on the bottom. So we did mostly development on AMD processors, from old one to some newer one. Our platforms span from PC engines through Asus, Supermicro, and ASRock. We used as a firmware both open source firmware implementation as well closed source based on UEFI. Then we, as a bootloaders and payloads, we used iPXE and Grab. And then on the kernel and hypervisor level, we used Linux kernel, Zen hypervisor, and landing zone, which we can consider secure loader and secure kernel related project. And that's why landing zone that's the only place where we have TrenchBoot logo, but to be honest, TrenchBoot contribution is spread around all this project which you see on this slide. Finally, on the operating system level, we used NixOS, which has very interesting capabilities. Please take a look at this operating system since it is very interesting. Yocto project, which gives us very flexible way to compile kernels and all the related components for TrenchBoot, for validating TrenchBoot, and then Debian for building packages which are easily to install and easily to test. Finally, in user space, we typically use two use cases for RTMs. Either it is remote attestation, either this is unsealing of the secret. So Chara is a Fraunhofer reference implementation or proof of concept implementation of RAT's IATF specification. So this is related to remote attestation. Then SafeBoot is a Trammell Hudson project which simplifies disk sealing and unsealing process, and we added the DRTM PCR support for this project. And then we have also Robot Framework, which is also user space, but it's not related exactly to TrenchBoot on the system, but more like a validation system. This is like a framework for performing automated validation in our labs. So speaking about hardware validation and our lab, This is diagram of the TrenchBoot remote testing environment lab. So on the left side, you can see that there may be various end users. Those end users either can get through some gateway, either through VPN, either through REST API, and can trigger tests written in robot framework. Those tests discussing with something called remote testing environment, RTE, which you can see on the middle of the screen. This RTE is an open source hardware project. All the schematics are public on GitHub, so you can either buy this from us or you can build yourself. And this is used for flashing SPI, for power cycling the platform, and like hooking into the platform and managing all the states of it, so it can be done completely remotely and completely automatically. Then we have like a bunch of platforms. Of course, I didn't put everything here, but we have like 2 racks of platforms that we're testing with RTE. Some of them are related to TrenchBoot. After these tests are made, there are some test results which are dropped into the spreadsheets for reporting. Right now, we're even working on Dasharo transparent validation system, which is a portal which will give the ability to better look into the test reports. In case of firmware contribution, first of all, we did the ACPI DRTM resource table implementation in Coreboot. So this is Trusted Computing Group compliant ACPI table, which inform us about where are the DRTM resources located. This is needed for next points for DRTM event log. So event log can be used for either debugging, either remote attestation, simplification of remote attestation, since it contains all the information about what hash was extended into the PCRs, and then also you can add someone who's extending that can add some note which explains what was extended. Then we did AMD IOMMU support for some platforms in Coreboot. This is mostly for PC Engine's APU2 and ASUS KGP D16. And then we also started some Intel stuff, but it's going very slow. There is not much resources related to that, but we're slowly progressing with Intel Ivy Bridge BIOS ACM support in Coreboot. The ASRock and Supermicro platforms were with the proprietary UEFI firmware, so we used stock firmware for validating TrenchBoot. And there was, of course, no contribution to closed source firmware. What we did on the bootloaders and payloads level, first of all, in iPXE, we added support for starting TrenchBoot landing zone. So right now, we are able to boot Linux kernel. Of course, it requires TrenchBoot patches, as well as Zen through Multiboot 2 support. So all the patches are on GitHub, and you can see how this is done. There are some small limitations to that, like to most things in TrenchBoot, but that was added and tested. For grab, we mostly did DRTM event log. So DRTM event log will be repeated here many times because it have to be supported across whole stack. So as I said, it allows remote attestation and debugging scenarios. And we did AMD SKIN core implementation in grab 2. So there are a couple patches that are still hanging on grab devel mailing list and awaiting for review. In case of kernels and hypervisors, for Linux, this was mostly done by ROS, but we did some improvements. This is not yet published upstream, but there is support in 5.8 Linux kernel for AMD Secure Launch. In Zen, we added minimal code to boot Zen through SKIN-LZ, and this was already merged by Andrew upstream, of course, thanks to his support. In case of landing zone, probably the most work we did is in landing zone. So first of all, we ported the SHA-256 implementation from Linux kernel to landing zone. Then we did variable separation, so we can keep hashes of the values independent of the memory layout. Otherwise, we will measure something that may change depending on the memory layout, and this defeats the purpose of the stable measurement. Basic support for forward sealing, so we added some basic scripts so we can then predict the PCR values on the next run, and that helps, of course, with forward sealing, which is one of the use case of the sealing and unsealing is one of the use case of the the early launch of the RTM. Then there are a bunch of patches awaiting review, like multi-boot 2 support. Of course, this was tested. It works with Zen, but still the patches are not merged into the LZ. There is of course the RTM event log support, which is also not merged, and then there was some early IOMMU support, but this is very basic, and this is very basic protection against DMA attacks, but cannot be merged right now because of the bug in DEV mechanism of AMD. What kind of things are still to do? In case of issues, we have 5 open issues. Those are mostly related to open pull requests, but not everything is public. There are some known issues which were not yet reported. I believe some cleanup is required. Then we have problem with IOMMU DMA protection. This cannot be implemented in secure way in current version of the processors or microcode. Maybe it depends how this can be fixed. So due to hardware bug in DEV mechanism, which blocks IOMMU from reading the configuration created in SLB, we cannot implement that in correct way. So this awaits some mitigation either from AMD, or maybe someone will figure out how to work around that. Then we need configurable builds, because LZ is just 64K, and definitely there will be builds dedicated to some types, or like some groups of machines, or some groups of platforms, and then of course this needs some configuration. So extensibility of the build process of LZ is needed. Then refactoring of LZ binary layout is also required after this long development, and then continuous integration and continuous deployment infrastructure improvements. Despite there is some work already made, we still need some improvements to make it work all the time, to be able to validate patches that incoming and merge requests that incoming to GitHub repository. Finally, it would be great to have PE header, because this will enable UEFI secure boot purposes, and this would help in joining the secure boot and DRTM words on typical machines, UEFI based machines. In case of operating systems, for NixOS we did support for TrenchBoot in Nix packages. So if someone wants to test on NixOS TrenchBoot, the kernel and all the required components like grab, LZ, and all necessary things for Nix, that's possible. We documented that on our blog post. If you are interested, please go there. There is also pre-configured Nix repo to host the components, and then there is also CI that can build these components, and then we can check like what kind, if build process still works, and as well, all the CI related stuff is there. Then we have Yocto. We created meta TrenchBoot layer. We still don't know what would be the future of that. Maybe it would be merged to some other layer, maybe to some, I don't know, meta security, or that's the discussion that we can make after the presentation. There are WIC plugins for partitioning, so legacy and UEFI partitioning is already supported. And we have also CI for meta TrenchBoot, so we can build the images and check those in our hardware validation lab. In case of Debian, we building all the required packages to run TrenchBoot, to execute DRTM through LZ. And yeah, we have package for landing zone, for grab, for Linux kernel, and this already works. We have also CI awaiting for that purposes. In case of user space scenarios, there are two major user space scenarios: unsealing and attestation, as I said. So first, for unsealing, we used SafeBoot. We added some support. We found some small bugs that had to be fixed to support sealing secret to values of PCR 17 and PCR 18. There is also possibility to use SafeBoot for attestation, but there is no server associated with that. There is like just simple TPM attest quote, and you got just getting target zip that you can send to some remote location for attestation. But still, this is supported. But main use case of SafeBoot and what was implemented is sealing secret and unsealing, and using that secret for encryption and decryption of the hard disk. Then Norbert did the Fraunhofer-Chara related implementation for remote attestation. Right now this is very basic, so just the verification of TPM quote signature is done. This signature is this TPM quote signature was generated by the Chara attester, so this is completely like unattended. Just attester kicks the communication with the remote server, and all works according to Chara and according to IETF RATS specification. Okay, to sum up, we worked like around 2,400 engineering hours. Some of that, or most of that, done non-profit, and this took us like around 2 years. So maybe this is not much, like 100 hours a month, but still, when operating without funding, this I believe was quite a big contribution from so small organization like TrenchBoot. We were able to create some contribution to 11 projects, and those either received patches and those were merged or awaiting review. There were 10 conferences presentation on which we promoted TrenchBoot. You can find those on our website in events section. There were 16 blog posts published, which you can easily find on our blog under tag TrenchBoot. And of course, if you're looking for experts in area of firmware, Yocto, NixOS, Debian, Chara, whatever software stack we mentioned here, plus DRTM or SCRTM, feel free to contact us. You can do that through either website, through contact subsection, or directly through email, or whatever channel you want. If you find me on social media or Michał, that's completely fine. Finally, I would like to give you a short pitch about Dasharo. So Dasharo is a kind of set of productized service, open core and SaaS products which we were able to build over the last 6 years to create scalable, modular, and easy to combine open source firmware, UEFI, and firmware solutions. So both open and closed solutions, or kind of mixed solution. It offers components that are not needed to develop and maintain. So those components are needed to maintain high quality modular firmware. So we have validation system, we have like build systems, we have like all the signing procedures and releasing procedures. We're doing that for some projects monthly for more than 4 years. So that's already tested and verified ecosystem. And how this is related to TrenchBoot. So the ultimate goal of TrenchDep is to leverage all TrenchBoot related features through the Dasharo ecosystem. So what kind of features you may see in future from us? So first of all, Dasharo provisioning, deployment, and recovery server. So how we envision that? We envision that as some kind of payload, some DLME which is kicked over network and gives ability to either provision the platform for some needs, either deploy some operating system or some configuration, or recover the system from the failure state. If we can kick that, let's say, before the operating system start. The same thing can be done for debugging server. So in that way, we are sure that we running only debugging software which is approved by the platform owner or by some vendor who wants to protect that. As well, attestation server, of course, this most probably based on Fraunhofer-Chara. Then definitely we would like to look into ability of implementing secure firmware update through FWPD LVFS in DLME. So we are already FWPD official consultants, and we would be glad to leverage that position to kick the FWPD inside the LME, and then in that secure space, like measured environment, do the update process. There is also a project about offline attestation, but I cannot talk much about that yet. You will probably get more information soon. And finally, through some requests from customers, application-specific solutions based on Linux and BSD environments. So one would be disk encryption decryption based on sealing unsealing process using DRTM PCRs, and system updates like Yocto SWPD system updates or some BSD system updates which getting through the DRTM launch process. Okay, so finally, how to join us? The fastest way is just register to Slack osfw.dev. On this Slack, this is open source firmware Slack. There is a channel called TrenchBoot. Feel free to join there and talk with us about your opinion about TrenchBoot, about use cases for TrenchBoot, and whatever you want about TrenchBoot, you can ask there. There is mailing list, of course. It's mostly right now very technical, like all the patches are going there. And finally, there is a website, trenchboot.org. Still not much there, like mostly links to the GitHub, but this is good entry point for learning more about TrenchBoot. So thank you very much, and feel free to ask questions either below the video or during the talk after this presentation. Thank you very much.